Okay, class, we're looking at set 2 problems for chapter 6 in lesson 5, and we're on page 268, and you will be doing set 3 problems, which are similar to set 2. And I'm just going to go again briefly just describe these problems. And we look at number 4. It says use the points labeled A and B to find the slopes of the lines in the graphs below. So all we're simply going to do is do our rise over run. We understand that slope is equal to rise over run, right? So if we just write slope is equal to rise over run, then we simply have to find out what our rise and our run is. Now to go from point A to point B, in the first case, we see that we'd have to first find where we're at with A and just put our if I were to, I think probably best to show it here. I will put point A right there where it would be on the graph, and let's see, B would be over 1 and up 1, 2, 3, 4, I believe. 1, 2, 3, yes. So that's our point A. 1, 1, 2, 3, 4. Okay, this would be the graph. Now rise over run. What would our rise be? Well, we'd have to go upward 1, 2, 3, 4 units, right? And so that's our rise. Let's write that down. And that's divided by the run. The run is 1. Okay, so that means our slope is equal to 4 over 1, which is 4. Okay, and if we drew that line, we'd see it's a very steep line. And you're going to notice that the higher the slope, the number over here, then the more steeper the line. Just imagine it this way. If I were starting here from our origin, and I went over 1 and up 1, and I found 1.1, what would my slope be? Well, it would be 1 up and 1 across. So my slope would be 1 over 1, which means my slope would be 1. Now imagine I take it all the way to 10. Now look how steep that is compared to the first one down here. If I drew this line, it would be here. If I drew this line, it's very curvy, sorry, but we could see that this is a much steeper line if it were straight. And my rise in this case would have been what? 10 all the way up to here. I would have counted from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I would have moved over 1, so it would have been 10 over 1. So my slope here would have been 10. So notice that this is a higher number, means it's steeper, and this is a lower number, it's not as steep. In fact, your slope could be almost, it look almost horizontal, just slightly. Let's say we went over here to 10, right? And our rise would be 1. We write it over here. And our run would be 10. What would our slope be? It would be 1/10 or 0.1. Okay, so look at the difference, the correlation to the slope, to the values of the slope. And we can see that we went from a lesser, and I'll attempt to draw that, okay, really bad, but we can see the difference to our slopes here, right? We can see that this is a much more gentler. If you had to run a hill, you'd probably choose this one rather than this one, wouldn't you? And that's because this one is much steeper. So just know that the higher this number, the steeper your slope will be. And it also goes again conversely with the negatives. If it's a higher, let's see, a greater negative, let's say a -10, -10 would come straight all the way down to here, wouldn't it? Whereas -0.1 or -1/10 would be here. So we could see that the slopes are different. Okay, so that's how we do number 4. Let's just clean this up and so we can get into number 5. And basically we're told here to plot. And we're to plot the following points and then draw the line and then find its slope. So the first exercise they simply drew, they did the first 2 steps for you, didn't they? They already put the points. Now they're asking you to go and plot those points, and I'm not going to necessarily do these because you already know how to do that. Plot the point on the graph and then draw a line and then figure out what the slope, and we know that we have to use the same formula of rise over run. Now we're told in number 6 to graph each of the following equations. So you can see how this is now becoming a little more difficult, but we've already learned that. Well, how do we get the graph? We've learned a couple of methods already. You can use those methods. You can find the x and y intercept. You can go ahead and make a table if you want. I think the x and y intercept might be the easier one because all you have to do is find what the y value is when x is equal to 0 and what the x value is when y is equal to 0, and you have 2 points. You connect the 2 points similar to what you did in number 5. You had 2 points, and then again figure out the slope by determining what the rise is divided by the run. So that's number 6. Now, number 7, we're going to give 7 is going to give us a series of questions or instructions where to draw graphs of the following lines. Graph parts A and B on one set of axes and parts C and D on another. So we need to have 2 axes. Axis meaning graphs, and what we're trying to do here is we're going to first the line through the origin having a slope of 1, 6. Now pause for a minute. Where's the origin? Okay, the origin is right here, and I apologize I couldn't get rid of this part. I couldn't erase all of this, but let's start with the origin. We have 1 point. They mention origin. Now they say that it has a slope of 1 over 6. So if our slope is equal to 1 over 6, we know what our rise and run is. We can find a point by we can find another point, and in fact we can draw this line by knowing 1 point and then finding the next point using the slope. Now it says 1 over 6. Now we know that 1 is the rise and 6 is the run. So let's do that. Let's go up 1 and over 6, which would take us right to here. Now I would be able to, and again I'm not going to get my straight line, I'm just kind of illustrating this. That would be my line. I would be able to draw a line through the origin. Okay, now I would really want to continue that line. I would have my ruler, and I could do something of this nature, and then you can just continue on afterward. Obviously that's not very straight, but with your ruler you can draw a much straighter line, and this would be a line that goes through the origin, and it has a slope of 1/6. Now remember we talked about before the slope of 1/10. 1/6 would be a real gentle slope, like 1/10. It wouldn't be like 60 of a slope or 10 or even 5. It's a very gentle slope, so you should visualize. Also note that it's positive. It's not negative. If it were negative, it should be going downward. Okay, so we did A, and we simply followed what knowledge we had. We just had to switch it around, and that's part of math, and it's part of learning algebra, and it's certainly a part of science. It's having certain amounts of information and then finding out what the missing information is. And the missing information here was, what's the second point, and what's the graph look like? Well, we had origin and we had a slope, so we can certainly work with that information and figure out the rest of the puzzle. So now it says here the line through the origin. So again, if we hear origin, we know what an origin is. It's 0, 0. It's right in the middle, and with the slope of -6. Now we again thinking negative. Oh, that's going downward. Now it's 6. Now before they gave us a simple one. It was 1 over 6, wasn't it? So we knew what rise over run. Well, if I have 6, what's the rise over the run? Well, we know 6 is simply 6 divided by 1. Okay, and this is where in the previous lessons where we talk about the simple things that are obvious, and this is where the obvious really comes into play, and we may forget the obvious. And we may think, well, I only have 6. I only have rise. I don't have a run. Well, 6 divided by 1 is really 6. So that means, but we also know that it's negative, right? So one of these two has to be negative. Okay, now I will certainly choose, in this case, the rise I will make negative. And I'll explain that to you later on why one has to be negative. In this case, we know that it's going to be -6. Why? Because we're going to drop. All right, so we're going to go down to -6, and then we're going to go +1 over to here. You see? And then we would draw our line, and again, my not so straight lines would take me all the way down to here. And we could see that we have a line that passes through the origin with a slope of -6. Okay? And again, when I spoke of using one particular number, positive or negative, I could have said +6 and -1. But that means I would have had to go backwards 1 and up +6, which would have put me over here, which really is in this line, okay? But we would have been working backwards, and I certainly don't want to show you the fundamental parts working backwards, but you can see how it works both ways, whether it's -6 and 1 or 1 and -6, because remember, this is the rise as well. It's a positive rise, but it's a positive that's going to go backwards, and we know that we're going from left to right always. So in the end, I don't go backwards, but when I do, I still have to view it from left to right, which means this is going from the up down. So it's going from this point, -1, down to 0. It's going downward. Okay? So then the last one, it says draw a line through -2, 5 with a slope of -3/4. Well, we would find our point. -2 would be here, and +5. Now it looks like a very busy area, but fortunately we have a nice clean point there. So this is -2, 5, and that puts us here, and we have a slope of -3/4. Now, if the slope is -3/4, again, we can go positive or negative. Just remember your rise and run. I typically will go with the with the rise of negative. Okay, so we'll make it -3, which means I'm going to go down 1, 2, 3, and I'm going to move over 1, 2, 3, 4, which puts us here, and this would be our line going this way. All right. And we know it's right because first off, we've been given a negative slope of -3/4. Now, I did mention that we generally give our slope in numbers, decimals, and they've been given them to us in actually fractions, which makes it so much easier. But if you would have told me I have a slope of -0.75, okay, -0.75, I would have had to have converted this into fraction. Okay, and this is the fraction. This is the simplest fraction. Now you might say, well, I can convert this into -75 over 100. Okay, that's -0.75. Problem is that our graph, really, imagine extending up and down 75. That's quite a few units to be traveling just to find the slope. We would simplify, and this problem here simplified is actually 3/4. So that's where your knowledge and familiarity with numbers and fractions really come into play. If you're not as familiar, you would have had to have reduced this by simply multiplying 25 times 3, right? And over here, this would have been 25 times 4, right? And that means you could have knocked out the 25s and you would have had 3/4, actually -3/4. So again, just toggling back to the decimal. Now we also are asked to do the same thing here in D. Find a line 5, -2 with a slope of 4/3, and that would put us at 5. Let's go out there, 5, and -2. That puts us right here. Okay, and the slope is 4/3. So we would have, I'm just going to write that over here. I know we're kind of getting a little all over the page here, but there's a purpose which we're drawing all these things. 4/3. That means I have to go rise 1, 2, 3, 4, and go run 1, 2, 3. Okay, puts me right here. So if I were to draw this, you'd have it that way. Okay, and so we've drawn all 4 of these. And having drawn all 4 of these, we are asked, what is the relationship between the lines for parts A and B? and for part C and D. Now, let's just take a look at the first one. We see this one, and unfortunately I haven't drawn this graph well enough, but this line and this line here, you're going to notice something. In this one, if you actually took it out further, this is going to be the C and D portion. Okay, it would sort of look like this. And simply the answer to this, something that we haven't necessarily discussed, but you should know, that these lines are actually perpendicular. You'd have to take a look at it, maybe turn your head sideways and sort of see that they cross. Now, unfortunately, because mine are sort of squiggly lines, it's much harder to see. But if you drew them with a ruler, you'd certainly be able to see that these lines are perpendicular. Perpendicular meaning that they actually cross through at a, these form actually 90-degree angles. Okay, that means the sort of like looking at our graph, that if you actually look at this as a horizontal, then this is perfectly vertical to the horizontal line. And again, mathematically, these would all be 90 degrees. So if we were looking at our original graph, our graph is X and Y are perpendicular. Okay, it runs at exactly 90 degrees from the other line, whichever way you look at it. So that was the answer. Now, number 8, we're told to graph the following linear equations. And again, you've learned a couple of techniques. I would use the easier technique. Okay. Then on number 9, it says, use your graphs for exercise 8 to give the slope and y-intercept of each function. Okay, so you should be able to determine that by just looking at your graph and taking some of the points and determine what your slope is and what your y-intercept is. Okay, and this is going to lead into the next lesson, which is going to be an even easier way to graph. You should be able to note something when you look at these, and if you don't, we'll definitely be covering this in the next lesson. And then we compare your answers for parts A through E with the equations of the functions without drawing their graphs. Tell what you think are the slopes and the y-intercepts of the following. So you'll notice that in 8 and 9, we have the same functions. All right. Just take a look at what your slope and your intercepts are for each of these and tell me if you spot them inside of the equation. And if you see the pattern, then take a look at F and G and say, oh, I know what my slope is and I know what my y-intercept without graphing. So that's really, it's kind of a prelude to the next lesson. So that's your challenge, and if you have any questions, you know where you can find me.